is just an extension of the tangent lines that we started in 12.1a. The nice thing about it is, because you are familiar with 12.1a, this should be pretty simple to start things off. So here's the first thing we're going to do. For this first example, we're going to say you have a circle. And in this one, on Friday, we said this line is tangent, therefore find the missing length or find the missing angle measure. Now, today, we're going to start it off with, is it tangent? So you have to determine, is it a tangent line or not? So I'm going to see if you can figure out how you would go about doing that in just a moment, once I give you, that was just my finger touching the screen. That's what happens with these rulers. I wish you guys could see my ruler, but you don't get that. All right, so if this is our setup and your radius is 5, this side is 12, and this side is 13, they're going to say, is it tangent?
Possibly. I have the answer.
Okay, they're asking about this line right here. Is that line tangent? What's the answer, Jillian?
Well, the answer is you have to see if it's a right triangle.
You do have to see if it's a right triangle. And how do you determine if something is a right triangle? Pythagorean theorem. So you're going to do the Pythagorean theorem here. If you know your triples well, this is a very quick problem. Is this a right triangle?
Yes.
5, 12, 13 is a triple. But you can always check it. 5 squared plus 12 squared equals 13 squared should be a true statement. If it's not true, then it's not tangent. Okay? So this is 25 plus 144 equals 169, and this would mean 169 equals 169, so it does work out. So is it tangent? We would say yes, it is tangent because it is a triple. Okay. Not that simple. I mean, that is simple. We're not done yet. Oh, stop. There's plenty in geometry that's simple.
I'm sorry. That was really I love this file.
Okay. How about this one? Yeah. All right, here's your next one. You have a triangle. I want to know, is this line, is that tangent to the circle? Well, that's just my poor drawing. That's the thing. You cannot judge based on what it looks like. You have to judge based on the numbers. Why?
Because 36 plus 64 is 100, and that is not equal 81.
Right. So it would have to be that 6 squared plus 8 squared equals 9 squared. And this is 100. And that does not equal 81. So if they are not equal, we would say not tangent. If they are equal, we say they are tangent. Okay? Okay. Majority of what you will do today is this concept. There is a theorem. It's Theorem 12.3, and what it says is if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. I'm going to draw you a picture of that rather than write it all out in words. Okay, so let's say we have this circle, and we have a tangent line here, and a tangent line here. Okay, so here's a point of tangency. Here's the point of tangency. The theorem says because they are both tangent and they meet out here, those two segments are the same length. So we're saying right now that those two segments are congruent. Okay, so if this is, gotta get my ruler out of there. Hold on. A, B, and C, for instance, we would say that AB is congruent to BC because they are both tangent to the circle, okay? So what you're going to end up doing with that is a lot of perimeter work. You're going to end up with triangles or pentagons or octagons or however many sides to some figure with a circle inside of it, and you have to figure out how big is that figure based on tangent lines. So I'm going to give you a few of these, and then we'll be done. Second example here. Let's say, you know what? I'm going to add this in just so you see. Oh, shoot. Again, my ruler is in the way. Just so you see their tangent, right? They're perpendicular, they're tangent. Okay. This circle. That doesn't look like a circle. That's better. Forgive me if this is not really drawn to scale. You can just use your imagination a little bit. The what?
Harry Potter.
Oh, no. I don't know Harry Potter. Is that kind of sad?
Draw a line from the top point down straight down, and you have the Deathly Hallows. The cloak, the stone, and the wall. If you control all three, you have the Master of Death.
I don't really. Okay, so let's say we know a few little tidbits of information here. We know that this is 5 units long. This is 14. And this is 8. Okay. There's a bunch of lengths that are the same. Now here's the deal. In this one, it's pretty simple. The way I set it up, it's really hard to do this one wrong. The next one I do, it's a little easier to do it wrong. You have to pay attention to where the point meets outside the circle. So right here, you have a point that meets outside the circle. That means that these two chunks are the same, okay? A lot of times people want to try to make it that these two are the same. It's not the two that are on the same line. It's the two that are forming a point outside, or that meet at a point outside the circle somewhere. Yeah, Jillian.
What are we trying to find? The perimeter of that?
Right now you're going to try to find the perimeter of the triangle. Okay? So they will say find the perimeter of the triangle. And then your job is to figure out, well, if this one here is 5, then this is 5 also. What is this length? That would be 14 because this one up here is 14. So this one over here is 8, okay? So that means our perimeter is just the sum of all of those. 5 plus 5 plus 14 plus 14 plus 8 plus 8, or there's 2 of everything, right? So 2 5s plus 2 8s plus 2 14s, will be your perimeter, and that comes out to 54. And then whatever your units are, I didn't give you units, so then it's just UN, okay? But where I feel like more mistakes get made is when it's not quite so just straightforward like that, and you get a picture like this. So first thing to notice, we don't have a triangle anymore, right? We have a quadrilateral. And here are the pieces that we know. Again, don't worry so much about is it drawn to scale? We're just going to pay attention to the numbers for now. To redo that 3. Okay, so knowing that this figure has all lines that are tangent to the circle, because they will tell you that, the lines are tangent to the circle, what is the perimeter? So again, we're trying to solve for the perimeter of our figure, which means in this case, the perimeter of the quadrilateral. So we need all 4 of those sides added together. Anyone see where you can start? Sam.
Kind of work your way around. So you start at the low 3, and the next one be 3, which means the next one be 5, now it's 5, and that's 6.
Right. Okay, so here's the deal. You have a 3 here, which means this is going to be 3 also. Okay, and because this is 8, the rest of that line would make this 5, which means this is 5, because those are the 2 that have to be the same. If that is 11, 5 plus 6 is going to give you 11. So what is this length? That would be 6. Okay, so this is, what's this little piece? That would be 3 to add up to 9. So this piece here is 3. Okay, something to note. This is not 3 because of that 3, right? That doesn't matter. This is 3 because of this 3. So just keep that in mind. It's not that it has to be the same as the line that it's on. It's the 2 that meet at the same point that have to be the same, okay? So if we add that all up, you have 3 plus 3. Here's the other place people make a mistake. Now you have all these little numbers written in. You need to either use all the little numbers or you need to use the big numbers, but don't use both. I would just do 8, 11, 9, 3, and 3, okay? So you add that all up. Let's see, 28 and 6 is 34. So your perimeter would be 34 units. That's nothing. Okay, questions on that? Okay, I have one last one. This time I'm going to give you the perimeter, and you are going to come up with a missing piece. Okay, so this is triangle P, Z, R, Y, Q, and X. So triangle PQR, okay, is the triangle that we're looking at here. If I tell you that the perimeter of that triangle is 88 centimeters, and say find QY. Actually, you don't need the segment. Okay, find the length of QY. So what we're looking for right now is this segment. How long is that segment going to be? Okay, that's our unknown. We know the perimeter. We know that this piece PX is 15. Oops, that's not my pen. And we know that ZR is 17. Sorry, that's not drawn to scale. What can we do? PZ would be 15 also, because this one's 15, so those two have to be the same.
RY is 17.
RY is 17.
And then divide by 2.
Right. Okay, so here's the deal. I would, just for the sake of you setting up an algebraic expression, I would call your two pieces here some variable, because we know they're the same. Okay, we know those are the same. So if those are both A, then I know that 2A plus 30 plus 34, right? So I'm just adding up all the pieces, has to equal 88. So if we simplify, then 2A plus 64 equals 88. We're going to take away that 64. So I get 2A equals 24. And then your last step is just cut that in half. So your A is 12. Okay. So you're just working backwards, but you're doing the same thing, right? So just give it a variable, and that simplifies so much. Any questions on that? Okay, you have about 10 minutes. That's all I got for you.